All right, guys, let's talk about some dimensional analysis real quick. So, dimensional analysis is something you learn about in Algebra 1. You go over it in chemistry, for those who've been in chemistry. But the idea is this, the dimensional analysis, the dimensions. When you talk about the dimensions in something, you talk about length times width, right? Like there are units here, right? So you get meters times meters, you're talking about meters squared. These are the dimensions. You see what I'm saying? Like, how you get from one unit to another. So dimensional analysis, just changing from one unit to another. So if we're looking here, we have inches, and they're converting them to feet. Now, you can totally do this math in your head. I get it. You're smart. You've done it since you were a little kid. But there's an actual math process to it. And the reason you want to learn the process is because when you get to really higher level numbers or really complex ideas, simply doing a one-step problem in your head is one thing, but doing like 5 different unit conversions is very challenging. So you want to know the process. The process is straightforward. It's a series of ratios or fractions, right, that you basically multiply against each other to change from one unit to the next. So if we're looking here, they're converting inches to feet. And the way you always want to start this is you take your starting unit, 24 inches, okay? Again, that's a fraction if you want to create it like this, over 1. Multiply by some factor to become a new fraction. But this new fraction, I want it to be feet, so I put feet over here. You always want to start out your dimensional analysis by putting your starting amount and then your final amount. And then, like I said, it's an analysis of the dimensions, analysis of the units. Okay, unit conversion is a way we can often phrase this, okay? Converting inches into feet. So what I need to do now is use the processes of algebra, which is canceling out different variables, okay, to convert inches here to feet. So what I want to do is I want to multiply it by a factor, okay, that these two inches and feet have in common, something that is equivalent. I don't want to change this value. So what I want to do is I want to multiply it by something that is 1, okay, something that has just a value of 1. So I can do that by finding some kind of ratio between feet and inches. That is 1, right? 1 foot is equal to 12 inches, right? Those two are the same thing. So 1 foot divided by 12 inches would just give you 1. Okay, so you're multiplying it by a conversion factor that won't affect this value. It'll just change the units because this right here, this conversion unit equals 1. So what I do is I look at this, and I want to get rid of this inches. So what I do is I put inches here on the bottom, and I put feet up here on the top. So I can convert from inches to feet. Okay, so what I need to do is I need to find a conversion factor here for feet and inches. Well, I know that's feet, 1 foot is 12 inches. So whatever the bigger unit is, I often put as 1. Okay, that's going to be my 1, and the smaller unit will be my bigger number. So in this case, 12 inches equals 1 foot. That way those two are equal and they can cancel each other out in value. So I just keep the 24 multiplied by a conversion. These numbers should all be the same. I hope I'm making sense. Anyways, just to simplify it, cancel here, get rid of the units you don't want, leaves you with the unit that you do want, and then simply do the math. 24 divided by 12, multiply across, right? And we know 24 divided by 12 is 2. So I get 2 feet. Okay? Multiply by the conversion units and cancel things out. All right? Now, if we come over here, if there are 2.2 pounds, 1 kilogram, how many kilograms does Mr. Ellis weigh? Well, you gotta know how much Mr. Ellis weighs. And that's the number. But anyways, we're gonna start here with this. We have 250 pounds, all right, times some conversion factor. Oh, my goodness gracious. In the middle of my demonstration. Okay, equals, again, changing it to kilograms, all right? Like I wanted to go live in Europe, and I need to know my kilograms. So I need a conversion factor, something to get pounds into kilograms. So what I want to do is, again, with my fraction, I want to put pounds on the bottom so that these two units will cancel, and then I want to put kilograms on the top so that it ends up on the top over here. Then I need my conversion factor, my equivalency, right? 2.2 pounds and 1 kilogram, they're equivalent. So I just put these numbers in here. 1 kilogram is equal to 2.2 pounds. The bigger unit always gets the 1. And so I just simply do the math. Multiply across. 250 divided by 2.2 gives me, oh gosh, I don't know if I'm clever enough to do that in my head. All right, at least in the time that I would need. 5, 4, 3, 2, 1. 113.6 kilograms. And again, be careful with the units. You gotta have the units as wise as dimensional analysis. But that's how I get that. As I have a conversion factor, I multiply by what I start with, and it gives me what I want to end with, which is kilograms. That's what we need, okay? But it gets more complicated, like the bigger level we go to. So in this case, please pay attention to like actual dimensional analysis. Okay, it says this: convert 24 kilometers per minute into meters per second. All right, 24 kilometers per minute into meters per second. There have been plenty of rockets that have gone into space that have come back down and were destroyed because Americans would use imperial units like feet, and then European or Russian or Chinese rockets would use something else in kilometers, and they wouldn't communicate properly. Converting units is important, okay, because rockets can crash. So if we take a look right here, converting kilometers per minute into meters per second. That's what they want you to do. So I want you to look down here at this. You start by writing your initial unit, 24 kilometers per minute. You see that right here, okay? And then you set on the other side what you want it to become, and you manipulate your units to get what you want. I want to change it to meters per second. So I can look at either one. I can get rid of meters first or seconds first, is up to me, but I'll start here with this. I'll put a conversion factor in here to convert kilometers to meters. So kilometers here, meters here. This way these two cancel. And you'll notice I cancel them in advance, so I know I'm doing it right. But if looking here, kilometers is bigger than meters, so I'm going to put a 1. But the question is, how many meters in a kilometer? King Henry died by drinking chocolate, let's see, milk. All right, so I want to go from my base unit, which is meters, 1, 2, 3, over to kilometers. Okay, so let me see, it's 3 units to get over there, so let's 10 to the 3rd power, which would be 1,000. And in fact, kilo means 1,000, so there's 1,000 kilometers there, or 1,000 meters in 1 kilometer. Okay, there's my conversion unit. All right, so now I got meters, which is good, check. What about seconds? Well, I got minutes here, okay? So let's get rid of these minutes. So I'll put minutes here on top, that'll cancel, and seconds on the bottom, that's what I want. But how many minutes in a second? No, wait, minutes is the large one, seconds is the small one, so how many seconds in a minute? And that's 60, okay? So now it's simply a matter of doing the math, multiplying across, because now I've got my minutes and my seconds, and these are now gone. Okay, so multiply across gives us 24,000 divided by 60. And if we do our math work right, 400. Let's see if that's right. It is indeed. And you'll notice I'll get this wrong because I did not put my meters per second. There we go. That's how you do a dimensional analysis. It's a long setup here, you see, with different units canceling each other out. Okay, to leave you with the units that you do want, and using conversion factors in between. Okay, so let's get to a real problem here, all right? This is one of the ones you're going to want to do. This is an actual AP class like level dimensional analysis problem, pulled from the AP website. So check it out. If there's a nuclear power plant that generates 1,500 megawatts of power, how many kilowatt hours would it produce in a week? So that's a lot. So let's take a look at what we have. We have here, we've been given 1,500 megawatts for a nuclear power plant. It's generating that much power, all right? We're gonna have to assume that that's in 1 hour. Let's just assume that for now because we have no other way of determining this. How many kilowatt hours would it produce in a week? So then we gotta figure out how much is it per week. So let's start with this. We have 1,500 megawatts and it wants to know about kilowatts per hour. So let's start by changing megawatts to kilowatts, okay? So how do we do that? Well, let's start with this. Megawatts. For those who've been coming on math practices, there are certain units you need to know. So you have giga, mega, kilo. And in fact, there's a tera over here as well. Okay, but kilowatts we know is 1,000 meters, right? So we say that's times 10 to the 3rd, because the exponent here tells you how many zeros to put, right? Because 10 times 10 times 10, right, is 100 and 1,000. So use the exponent there to know how many zeros to write. That's a quick, easy way to do it. Just some math flexing there. Over here we got megawatts. Megawatts are 10 to the 6th. Okay, so we're talking 1, 2, 3, 4, 5, 6 zeros, 10 to the 6th. 10 times 10 times 10 times 10 times 10 times 10. Yeah. Okay, and then over here we have gigawatts. That's to the 9th power, so you have 9 zeros. Terawatts, 10 to the 12th power. Okay, so what I try to pay attention to is knowing these units, okay, and memorizing this, because you're going to have to memorize it. I'm going to figure out how to get from megawatts to kilowatts, or at least how many kilowatts are in 1 megawatt. So we're looking here, right? We have kilowatts and megawatts. I need some kind of conversion unit, okay? So let's see here. Kilowatts, megawatts. I always said make the bigger one the 1. So mega is bigger than kilo, so I'll make this the 1. And I got to figure out how many kilowatts are in a megawatt. Well, what's the difference here? Well, the difference is 10 to the 3rd power, right? This is 10 to the 3rd power, so I gotta go 1, 2, 3 hops. That's 10 to the 3rd power, so that's 1,000. So essentially what you have here is a megawatt is 1,000 times larger than a kilowatt. So therefore it would be 1,000 kilowatts in 1 megawatt. That's my conversion factor. So when I come down here, I have 1,500 megawatts. All right, and I want to convert them to kilowatts. So that was megawatts on the bottom, and that's my larger one, it's the 1. 1,000 kilowatts, and that should convert, giving me 1, 5, and I have 1, 2, 3, 4, 5, 0. 3, 4, 5. Yep. And that's kilowatts. So that's how many kilowatts I should say it makes in an hour. That's pretty good. Okay, so that's how much it makes in an hour. So we converted this unit to kilowatts. The question is, how many kilowatts would it produce in a week? So if I reset this problem, oh, of course you would. All right, bring this guy over here. All right, so this is how much it produces in an hour. Okay, so then what I want to do is I want to figure out how much it produces in 24 hours, because that would be a day. So I'll multiply by 24 hours. That'll give me kilowatt hours. Right, because I want kilowatt hours, so kilowatt hours is there. Okay, all right, so I'll multiply here, and that will give me, do the math. I can't do that in my head. I'm not clever enough. 3, 4, 5 zeros times 24 gives me, okay, 3.6 times 10 to the 7th. So that's great. Put that down. But here's the problem. I also want it to be, that's how much in a day. 7 per day. How about the week though? So that's in a day. Then I can do it to a week by multiplying by 7. Because there's 7 days in a week. Yeah. So 7 days. So how much in an hour? So do that over 24 hours. That would be the amount there. And then over 7 days, multiply by 7. So I take the number I just got, multiply it by 7, and I get 252. Good grief. 252 million. That's pretty good. Okay, so there's my number. 252 million, what is that? Kilowatt hours per week. Yeah. Okay, answered. Now, what they always do is they take that number and they put it into another part of the problem. So looking over here, it says, using the answer from the last problem, if every household in Georgia uses 8,000 kilowatt hours per year, how many houses could that nuclear power plant support in that year? Okay, so we know that it produces this many per week. Kilowatt hours per week. And I want to know, using the answer from the last problem, there we go, if every household in Georgia uses 8,000 kilowatt hours per year, how many houses could that power plant support that year? So this is per week, so I want to find out, if this is per week, how much it is per year. So this is per week, I know I want, there's 52 weeks, right? So if I want this number, I want to multiply it by 52 weeks. And that's in 1 year. And that will cancel my weeks out and leave me with kilowatt hours per year. Yeah. Okay, so we do the math. Let's take that number times 52. It gives me, oh my goodness gracious. 1, 3, 104, 1, 2, 3, 4, 5, 4, 5, 5, 6. I think that's right. You can see why we use scientific notation, huh? All right, so we got this huge number here. Okay. Now, that is how many kilowatt hours per year. And so, again, making sure I'm doing my math right here. I got to make sure I show my math. So then I want to know if they use this much per year. Each house uses 8,000. Oh my gosh. So if I have 1, 3, 104, 1, 2, 3, 4, 5, 6. Okay, so if I got this number here, and that's how much you use kilowatt hours per year, how much is made, and then I know I have 8,000. All right, 8,000 kilowatt hours, yeah, per year for each house. Well, it's for each house, then I want to divide by that 8,000 to find out per household. So kilowatt hours per year per household for one. One household makes that much per year. So that means that these units will cancel, leaving me with the number of households. Right, so 8,000 per year per household. Okay, so there's my total. Divide by the amount used by each house should leave me with how many houses. So divide by 8,000. That gives me 1,638,000. It's pretty good. Okay. That's how you do a dimensional analysis. And in AP, like the numbers can be crazy. You have to be okay with that. Don't assume that you're wrong just because you get a weird decimal or because you get like a weird answer. Like the answer should make sense, right? Yes, but at the same time, like just trust that the numbers sometimes don't always work out. Like you get some weird answers sometimes, but because you're just not used to using real numbers. Like these are real numbers, okay? Millions and thousands and kilowatt hours. Like these are real things. And they give you an answer, so just follow the math. Make sure it works out. Okay? There's a practice problem similar to this on my quizzes on Canvas. It's way easier, okay, than this one was. But it's doable. I promise if you follow the method. So good luck, okay?